On September 23rd, 2003, AMD released its long-awaited processor, the Athlon 64. The processor at that time was released at a speed of 3200 plus, which actually operated at 2 GHz. With a core stepping of C0, which indicates that there had been some revisions to this core prior to AMD's releasing it officially, which gives a good indication as to why this processor had been delayed for some time. AMD had been talking about this chip for probably about 2 years before it had been released, and it had been delayed and delayed and delayed, and finally when it was released with 1 megabyte of level 2 cache as opposed to 512K, which they had been saying from the start it was going to come out with. This was believed to have been done because AMD needed to play catch up with Intel because of all the delays. The processor did eventually come out with 512 kilobytes of level 2 cache in the Clawhammer core, but the initial release processors were 1 megabyte. But in this video we're not going to be taking a look at the first officially released processor, no. We're actually going to be taking a look at the processor that was released before this, 10 months before this as a matter of fact, back in December of 2002. And that's this guy right here, this reddish brownish PCB chip right here. It's an Athlon 64 with a part number of 2800. Now this particular processor is a 1600 megahertz part as opposed to the 2 gigahertz part of the 3200 plus. This has a core stepping of B0, so it's a step earlier or thereabouts than the officially released chip. This also has 1 megabyte of level 2 cache on it. And as you'll see in a minute, this processor doesn't actually have the 2800 speed rating when you turn the computer on, but it's actually a 2600 rating. So they labeled the chip a 2800, but it's really a 2600. I don't know, it's kind of a strange mishmash of things here. But nevertheless, I do think the 2600 rating is accurate given that the 2800 plus is actually an 1800 megahertz chip, so that would make sense. It also has some curious markings on here for stepping codes like AAABB, AAACB, things like that. It's almost like someone got happy with the keyboard and just started pushing numbers and didn't know what, and letters. They didn't know what they were going to do here. AD, AAAAAA, 2800 AC, and 5. It's like, okay, that's a lot of A's all over this processor here. It's like, oh, this is the A chip, I guess. I don't know. This was a 130 nanometer process technology there. Single core, obviously. And it has all the same features that the rest of the processors had. It is a Clawhammer. But making this an early example of the Clawhammer core is what makes it interesting. And this is the processor I'm going to be taking a look at here in this video. Now, as far as I know, this does not have power now and cool and quiet features built into the processor. So I believe the 3200 plus did when it came out. The officially released one did. This one doesn't have any of those built into it. So this is like really, I mean, kind of early stepping. They must have decided to add that stuff later on. Obviously, someone had a brain fart and said, oh, we got to get that out there. We got to get that out there. Yeah, it's kind of funny to see. This isn't exactly considered an engineering sample as far as I know, but it is considered a pre-release processor. I don't know how many of these things are out there in the world, but the guy I bought this from had a bunch of them, and I'm guessing that these probably got pulled out of HP computers because HP seems to be the weird company that gets a hold of these chips somehow, some way, engineering samples or whatever, and they wind up in the machines that they sell. And yeah, I don't know where else they would have come, how they would else gotten into the market except an OEM. There was also probably some other bug fixes in the revision of the processor that they had to fix, and I don't know, the processor seems to run fine for me. But the one thing I will say is that this processor would not run on the ASRock Enforce 3 chipset motherboard. I do not know why. The other Clawhammer processors run fine on it, but this one would not post. So that's why I got this SYS chipset here, which actually is a pretty decent chipset. This WindForce board with this SYS 775 chipset is pretty decent. It's a little weak on the overclocking front, even though it does have the ability to lock the AGP and PCI buses separately from the bus speed. There is no way to change the multiplier in this BIOS, which caused me a problem when I started getting to the benchmarking and comparison portion of all this fun testing stuff here. So for the comparison, I used my Clawhammer core, mobile 3400 plus, and I just clocked it down to 1800 megahertz. Now, because the BIOS didn't support, it doesn't have the option, I should say, to be able to change the multiplier in it, I had to rely on software to do that. And this is a pretty good utility for doing that, so I was fine with it. I did have some locking up problems with this utility when I'd switched the multiplier. It doesn't seem to take to changing the multiplier on the fly very well. This motherboard also was unable to run this chip at default multiplier. I was clocking this chip only with a 4x multiplier, which gave me a speed of 800 megahertz, which was noticeably slow. So that's one reason I had to get this thing clocking up to where it needed to be for this test. 1800 megahertz, like I said, is where the true 2800 plus runs at. So that's what I clocked this chip. Again, the original release of these processors all came out with 1 meg of cache. This chip has 1 meg of cache. Like I said, the Clawhammer is a little bit newer revision, but the performance isn't going to be really any different than a true 2800 plus. So that's what we got to work with. And I would have liked to have done maybe a comparison with a VIA based board. I just don't have one at this time, so if I ever get one in the future, maybe we'll do that. So let's go ahead and take a look at the benchmark results here. So for these comparisons, I'm running the Radeon 9800 XT with Catalyst 6.2 driver. And first one we look at here is 3D Mark 2000. The pre-release 2600 chip, aka 2800, is 18,093. Not too bad. The 2800, which is running at 1.8 gigahertz, is 18,825. Of course, we'd expect it to be a little bit faster, and it is just a little bit faster. 3D Mark 2001, we're doing 17,814 for the 2600 and 18,129 for the 2800. Not too far apart there, pretty daggum close. 3D Mark 03, 6269 versus 6678, again fairly close. The 1.8 gigahertz though is definitely pulling ahead a little bit, more noticeable than it did with the 2001, but still fairly close. 3D Mark 2005 here, we're doing 2467 versus 3234, and 3D Mark 2006, we don't have much between the two here, 1026 versus 1033. Now at this point, 3D Mark 06 is really too much for this combination. Even 3D Mark 05 is really too much for this combination. Great video card, great processors, but it's just a little bit out of this era of hardware's ability to do that. Aquamark, we're doing roughly 46 frames per second versus roughly 47 frames per second here. So basically there's a frame a different, roughly 1.5 frames per different between the two chips. Quake 3, we're doing 1280 by 1024, 298 versus 306. And I would like to point out in these tests that I'm going to have to go back and rerun the benchmarks for the 3400 plus when I was running it overclocked, because this motherboard, the scores that I'm getting are actually quite competitive even with that. So I think that I'm going to have to, I don't remember, I didn't write down what driver I was using, and I found out that the revision 9.1 driver, Catalyst 9.1, was quite a bit slower with this video card than the 6.2 was. And I might have been running the 9.1 on that other one, and I didn't have any clue about that. So At some point I may have to rerun those benchmarks. But you can go back and watch that video if you want to and compare these numbers, and you'll see just how close they actually really are. So looking at Doom here now, 1280 by 1024. We're doing 39 frames per second on both chips. I think there might have been a half a frame per second between the two of them in reality, but I just rounded them up. Unreal Tournament here, 1024 768, 44 versus 48 for minimum, 156 versus nearly 200 maximum. I don't know why the maximum was so high there, and average 81 to 85. So again, you know, it's a little bit better with an extra 200 megahertz, but not really too much. I don't know. Final Fantasy 11, 4353 versus 5148. Now this is a benchmark that we do see a pretty significant difference in the numbers there. I'm not exactly sure what the numbers mean. I don't think it's frame rate, but it just is a counter as it goes through the loop of the benchmark, and that's the number it gives you, and the higher the number, the faster it is. So there we go. Look at Halo here. I decided to dig out Halo. 58 versus 61. Again, there's not much difference there, but there's a little bit of a difference. At 200 megahertz makes a difference, but you know, it's not really that much. So when taking a look at both of these processors and these benchmarks here, yes, the extra 200 megahertz does make a little bit of a difference most of the time, but not really a huge difference. So, you know, this pre-release Athlon 64 2800, you know, even though it was re-rated at 2600, or I don't know if it was re-rated or mismarked, or I don't know what the deal is with this thing, but it's not that far behind a true 2800, or at least in my estimation of a true 2800 here. So, you know, I don't know. I think that if you had bought a machine that claimed to have a 2800 processor and it was really running at 2600 speed, I don't know that you would have really noticed the difference between the two of them. I mean, I can easily with a different driver, as I said before, I can actually make the 2800 in this case run slower than the 2600. So, you know, and different motherboards, who knows? I mean, I don't know. It's kind of interesting, but you can see though that 200 megahertz doesn't really mean a whole lot between these two chips. You've really got to start getting a few hundred megahertz more, you know, 5, 6, 800, a whole gigahertz before you actually see a meaningful difference of numbers between these processors. But that's been true for a long time. So anyway, this is a little bit of a look at a rare and unique vintage processor here. And you know, this was only $10 for this processor, and I think the guy still got some. I thought this processor was bad because it wouldn't work in that Enforce 3 board of mine. Like I said, I don't know if it's the motherboard, if it's the BIOS, or if it's the chipset, but it wouldn't work on that board, even though other Clawhammers do. So who knows what the deal is with that. It does work on the sys. I have no idea about the VIA. So if you wanted to get one of these unique processors and have something unique running in a vintage system like this, that's just something to keep in mind. Yeah, it may not run in your motherboard, and I don't really know why. There's not enough data about this processor to really know why things are the way they are. But it's a 10-month earlier processor, which kind of makes it unique. It's like an engineering sample, but it isn't, I guess. I don't know. Anyway, hope you guys liked this video. I'm going to get to a Intel, I think, on the next video. Intel Pentium 4. Actually, not Pentium 4, it's a Xeon system, actually. Quite a unique system. There are some videos on YouTube of it. It's a Dell. Just to give you a hint. It does have a Xeon in it, but it's a Xeon. It's an LGA 771, but it's a Pentium 4 LGA 771 Xeon, which is kind of interesting. It's the equivalent. The Xeon that's in it is the 5080, I believe it is, which is equivalent to the Pentium D Extreme 3.73 gigahertz processor, and this board can take two of them. So I'd like to get a second one of those processors just to see what quad Pentium D power would be like. But that's for next time. See you guys right here in the Wayback Tech channel later on. Peace out, everybody.